So I want to cover a question that's come up quite a bit about the Apple TV. The question is, why don't I just take the board out of it and put stuff all around it? Which really would be great to do. It gives me a lot more options, but believe it or not, the design of an Apple TV, although they didn't intend it for high performance, is just really great for high performance. Let me explain. Okay, so here's the guts of the Apple TV. So you can see the jacks on it and everything, right? And on the top, this is the bottom. On the top is the power supply. So this is the power supply that's normally in it. It's a stock power supply. And you see there's some room here. This is important room. This is where you can put stuff. But you can tell how serious Apple was about hooking this power supply to the board because there's bolts, right? Not just a little wire or a little connector. These things are bolted. And that's because the Apple TV board itself generates so much power, so much noise, that in order to suppress it, this cap has got to be, with other caps here, is pushed right up against that board to try to remove the noise from the board, to try to suppress some of that noise. Anyway, so where is it? So it's inside here. So what happens is you take this off, and this is a solid piece of metal. This is thick. I mean, it's not a 1/4 inch, I guess, but it's pretty thick, and it's one solid chunk of metal. So this is amazing shielding. Okay, we're not fooling around. This is shielding here, and you'll notice that there's this area here that's part of the RF shielding. So what happens is that actually makes contact with this RF grommet here, and so what happens is each section of these boards is completely enclosed and RF tight, which is really amazing. You don't see that really in hardly any kind of products. I see it in test equipment. You see it in a lot of RF gear. But to see it in this kind of a product is kind of remarkable. Because of the thickness of the metal on both this part and the other part, the top and the bottom, this thing basically doesn't get any RF from outside at all. The shielding is just sort of absolute. Obviously, noise can get in through the connectors, through the power supply, right? But as far as any, through the air, and this thing's it also doesn't radiate anything. So if you put it right next to a piece of gear, right, you're not going to get a bunch of noise coming from this device. Now, the problems. So how this works is these pieces, these metal pieces, are here for heat shrink or heat sinking. You can see the compound that they just stuffed in there and just kind of gooed it together. And so each piece of this, why it's so thick, and this is a fan, is to get the heat out. So the board is sandwiched very tightly between these two pieces, to where that RF gasket, there's literally no gap. So this is a really great design. Now the bottom part, we take this part, is the same idea. On the bottom side of this, you've got the same thing going on. You've got a big RF section, a very well-defined, set of shielding, along with all the RF gaskets. So this is actually an amazingly well-designed piece of gear from an RF standpoint, from a lot of standpoints. But you see the problem. You see how there are these little divots, right, that are unbelievably tiny. They're like a 64th of an inch. But that's because this metal squishes these two things together in such a way that even those little spots, which correspond to the parts over here, basically there's no room inside here at all. I mean, there is not even a 16th of an inch inside here. The only gap that you've got is the gap between this RF, the top of this RF, and the inside of there, which really is the height of your standard chips. Well, these are very tiny surface mount chips, so there's no gap in there at all, which is actually good, because that's a very tiny area, so it produces an RF cavity. Some of the mods, though, have to do with suppressing some of the RF, because this RF will then reflect all around on these other parts inside this space. So using some RF suppression in just the right areas really does miracles. for the whole thing, along with everything else. So the other advantages to this board that Apple, I'm sure, never intended, is that by having all of it, the entire thing, they didn't have any room. So they had to use minimal part counts. Hey, boy, minimal parts is good, right? So, so that's what they did. This whole thing has very few chips. That's the CPU, right? You know, you got the Ethernet chip. You've got, you know, it's very few parts. So that's a real big advantage. Also, they're using the smallest scale of SMD part, which actually is really good because it puts, there's very little trace distance between anything, which is actually a really good thing too. So, so overall, and now the ground plane is really good. You can't really see it in this, but there's a really good ground plane between the two, and the power supply plane between the two, and it isolates the top and the bottom. So this is actually a really amazing design. This is a CPU, an SSD, Ethernet, an HDMI chip, all of it in the space of a couple of square inches, which is, and the shorter the distances between chips, really the better, because there's less loss and less noise induced in between all those parts. So by having everything in such a small area, using all this great RF isolation and shielding, you know, using these solid metal pieces, you know, these thick solid metal pieces to shield all of it, really makes this a remarkable product. They didn't intend it for our use, you know, to make it really super high end, but it sure works that way. So this is where the power comes in here. And this is where I do all my measurements for the power rails that I put up on the spectrum analyzer and all that. So, so it's quite the product. It really is. It's very tiny, and it has an amazing amount of performance. It has an A12 chip there. There's just, this is really amazing. It comes from their ability to put everything into a phone. So by squishing all this down to such a small area, using really good RF shielding and all sorts of good power plane stuff, using state-of-the-art in trace routing on a PC board, you know, they've done everything right. So this should all stay together as one piece. It should never be opened, you know, and gotten rid of. You don't want to lose any of this because this is all really great. Anyway, well, there you have it. That's what I wanted to cover.